Hi everyone. In this video, I will be talking about multimodal RAG. So let's start without wasting any time. Here I will be talking about how we can perform multimodal RAG in a document which has table, text, image, and also chart. It can be having the diagram also. You can say whatever natural document we got and that we will be processing. And the first I will be explaining the step, then we will be going to the further. First we will be extracting using unstructured.io based PDF loader. Uh, then we will be going to the table transformer, which is state of art for extracting table from the document. But unstructured.io PDF reader under the hood using that one. So we don't have to do all these things. And third step is we will be extracting images, including chart with same unstructured PDF read loader. And then we will be storing into the directory. And next will be like we will be converting to the HTML table to Markdown. The main reason why we will be doing, even if you use the normal LLM based chat like Chat GPT, when you will ask them to create a table, they will be creating a Markdown table. If you copy that one and paste somewhere Sublime, then you will see that table is Markdown table. And so that from that we understood like LLM are very good at understanding the Markdown table, so we will be feeding them to markdown table only, not HTML table, which is given by the unstructured PDF reader. Then we will be summarizing these data like a text data, image data, table data. We will be summarizing those data. Then then we will how we will be summarizing? We will be using the prompt with Chat GPT-4o Chat GPT. So GPT-4o we will be using, and we will be sending our text data, our table data, and we will be getting to summary. Then like we will be converting the images to base 64 string. Uh, the reason why we will be converting into string format, LM currently ChatGPT understand the string format of the image. So we will be converting them, and then we will be getting the summary for the images. Now we will be having text summary, table summary, and image summary. Now we will be storing these summaries into a vector database. For that, we will be using a Chroma DB, and to convert a document into vector database, we will be using a OpenAI based embeddings. You can use other sentence transformer based also, but we will be using the GPT-4o based embeddings. And the raw data is stored into the document store. Currently, I am using a Redis. You can use any Elasticsearch or any other document is supported databases. And especially when you are handling the million or billions of the documents, Elasticsearch are always the better choice as of now. And for the creating the embedding, we will be using for text embedding 3 small, and it is dimension is approx if I remember 1536. That is the size we will be using. And then we will be creating a retriever, and it will be like retrieving the from both databases, our embedding database and our document databases, and we will be getting the top k document. And then we will be creating a model prompt like where we will be sending all our extracted data to a GPT-4o mini based LM, and then we will be getting that answer. And then we will be like formatting them to better represent the answer. And then we will be creating a Flask based server so that we can host that one. And as we are using the API, we will be using a just a fast API based server. If you are using the open source LLM like Llama or Phi, then you can use VLLM, which is the best for the inferencing related stuff. So let's start one by one. First, here we are installing the dependencies like mainly LangChain related, LangChain, and for OpenAI, LangChain OpenAI is there. For ChromaDB, LangChain community is there. Then other community and experimental. And this is the here we are installing the unstructured. All docs means we will be supporting all type of docs. Here, if I will put PDF, that means only PDF I am supporting. And then for the as I told here, like we will be converting table into the markdown table into the HTML table into markdown table. For that, there is a library HTML table to MD means markdown. And then we will be having the tesseract OCR and proper utility. Mostly it is used by the this unstructured library to extract data from the PDF. And then we will be getting the download, and that file is downloaded, and we will be removing the first figures like images. And now we will be reading the PDF using unstructured.io. Hi, I have fixed the issue. It was the library issue. Now we have extracted the data, and number of the chunks we have 7, and I will tell you what all these are doing. Strategy is equal to high resolution, mainly because we will be extracting a table and all the format, so it should be high resolution. And then extract PDF images in a PDF is equal to true. That means we are also extracting the images from the PDF. Infer table structure is equal to true. That means we will be also getting the table from that, and for that we will be using table transformer. This model is table transformer model or safe tensor. And for the images, we are using the YOLO. Then chunking strategies like by title, we are like chunking that one. Max character is 4,000, and new character after 4,000. Combined text under if it is less than 2,000, combined to the uh, other chunks like which was present into the top or start the new. And the mode is elements. Elements means we will be extracting table, image, and all these things. If we have put table or text here, then it only table it will be extracting. And output directory for the images, we will be here storing our images. Then we have loaded, and then here are 7 chunks we got. And if you see the category wise, so this is the data. First one is the composite. Composite means it has the text and images, and table means normal table. And zeroth element, if you see that, then it is complete text, and it is start page content from here. And the fifth element, which is the 1, 2, 3, 4, 5. Fifth means 6 elements. Sixth element, which is the table. You can see here, it is a table. And then I will be just like checking that one images like in the format. Like first is page content we are pasting. This is the page content which I was showing to you. And then as a HTML, if you want to see like then there is a metadata attribute inside the data, and you can do dot metadata text as HTML. Then it will give you a table structure for complete HTML table structure. Yeah, now we got the HTML table structure. You can display the markdown if you like a table as metadata and all these things. And that for that only I imported that these dependencies. And this is the markdown table to table as HTML. We are just displaying that one. You can see that table transformer beautifully extracted a table. And this type of table where the one line is text is there or other is empty, these are known as complex table. And complex table, handling the complex table is the one of the difficult tasks. Still a lot of improvement it need to do. Like for example, Here it should be 4.1, it is 41. That means it is missing the point. So there is area of improvement, but still table transformer is a state of art for the extracting the unstructured tables. And then we will be converting to the table into the markdown format, which is this format. You can say same table I have converted to this format to this format because model understand this better. So we will be doing this one. And if you want to see that normal table way, so then this is the format like a normal text. And here like we are just like creating the two arrays. One is the for docs, one is the for the table, and according to category type we are just appending that document. And we got that key 5 documents are there, 2 tables are there. Document means text. And then we are converting tables like we said na ki model understand table as a markdown. So we are just converting here HTML table to the markdown and convert table, just we are converting here. And then after converting, you can see that now inside our table array. Wait a minute, here I have to do this one. Now this one, yeah. Now you can see that in our data set, we have table in this format and model given us to this format. This was the table transformer given us, and we converted to into markdown table and complete data set. And the images are stored here, like we have given the address. So here we found out ki we have 5 images. And if you display, this is the first image, complete image, like a normal image. And this is the chart. You can say this is the another chart. So you can say here charts are there. You can say this is a table where years and the area burn is there, also number of the fires also there. So it is table, you can say in the graph chart form. Here we are getting the OpenAI key, and then you have to pass your own API key. Here I have given mine, and then I am creating the chat GPT based. I am using here LangChain to create a GPT instance, and here is the I am creating the prompt. Key you are assistant for summarizing table and for text for particularly semantic retrieval. You can say here I am telling him the model you have to convert summary for the table and in text, especially for semantic retrievals. And then I am passing like my data. So here you can say I created the prompt template from text. This one is the prompt I have created. Then this is a chain, LangChain where I am passing in an element. I am passing the here it will be there. Like these are the document summarize change or batch. Here document I am passing. Then we got the this text. Then we are getting the prompt. Then is we are feeding into GPT. Then we are parsing it. So you can say a complete flow is here. Text summaries we created for the text document, table document. Like here we are just getting the text format from the document objects. And we are here in the batch, we are converting the text to the summaries. So here we got the table summaries and the text summaries. Again, we check the length. It is 5, 2 because 5 text summaries were the text were there, 2 tables are there. Text summaries, you can see here. It is giving the table this table provide information of wildlife statistics of United States, and here table information is there. The table provide the data for number of fires and acre burn from United States from 2018 to 2022. If you see here, I think this is the only table. 1993 to 222. This one only 1993. I think 2018 to 2022. I think different one is there because 5 are there. So that takes some. Here what we are doing in next phase, we are doing, we are converting the image into the base 64 strings, because GPT model understand image in string format. So we will be converting them, and then we will be sending that one. This is the here we are converting simple library, base 64 library. We are encoding that image into the string, and just it is giving that one. And this is the same summary we are sending, like make image summary. And here we are just creating the image summary related prompt. And here we are saying ki generate the summaries for base 16 code string. So the prompt, and this is the more you can say prompt we are adding. And here we are doing all these things. So whenever images is there, I am getting the image path, then I am converting image into the string. Then I am appending this one like image list. Also in the summary, I am calling image summarize. This one, this model, where the creating a chat, then chat dot invoke human message. This is the prompt we created here. This was the comment, you can say document comment. And this is the prompt which we are passing. And this is the base 64 based like a string representation of the image. We are adding also image URL and image URL this way. This is the structure which GPT understand. This is fixed. Okay, this way only we pass the images. So so we are using this one. We are sending, then converting the image to a string, and then with prompt we are sending, and we are getting the image summary. So we are appending the image summary also here. And if you want to check here, you can say we call this method generate image summaries, which does all the tasks. And you can see here 5 images were there, 5 summaries we got. And display image, we are displaying the image like this was the image 1993 to 2022. If you see the image summary, it is saying same line and area chart depicting the number of fire and acre burned from 1993 to 2022. So you can say even it giving the information, normally we were not able to do. And this is the better, like we are not getting anything previously. Now we will be getting a lot of information. Whatever we can see, almost everything is there here. And this will help us to retrieve this image. And then like here, I am just creating the Redis server. You can use Elasticsearch, and a lot of document storage are there. You can do anything here. And here I am creating the OpenAI embedding model. Now I got the summaries. Now I have to convert those summary into embedding so that I can store into a vector database, which is ChromaDB. So I will be storing here like this is the import, create multi-retrieval. And how will be I will mapping those one, like there are two stores, one is vector store, one is the document store. So I will be using a document id, using document id we will be linking both data in both databases. So this is where multi-vector retrieval class of the LangChain is there, which do the same task for you. Like you don't need too much here, but just define this way, like document store is equal to document store, vector store is equal to vector store. And this is the key where you will be giving the same for both. So this is like a LangChain do a lot of the task for you. And here we are just we are adding the document, like if you see that here we are getting the summary document. Here we are creating the metadata, which is the id, UUID we are just creating, and nothing more than that we are doing. And here we are adding to the vector store. Here we are adding to doc store. You can say just a normal operation of the of doing this one. And then here we are adding the document. We are here adding the table summary. Here adding the image summary. You can say we are now we in created a like a multi retriever. In that also we added everything. And this is the method to I will be calling down. So here ChromaDB, like you can say we are given name is multimodal RAG. Embedding function, I told you ki we will be not creating by oneself. We will be just giving the embedding model. ChromaDB will do under the hood all the tasks for us. and this is the collection metadata feature, which is the approximate nearest neighbor searching related algorithm. How you will be how we will retrieve those algorithm is there. You can check in the Google. These are the for the approximate nearest neighbor search, and this is the one of the most used as of now. So we will be using same. We are creating the Redis, you can say, document store for us. So now we have both databases, and we just call this method by giving that vector store and document store, and it will do all the tasks. Now after that, what we are retrieving, we are giving the this retrieval. That means now we have the uh, information related to our database, multi-vector database. This is the multi-vector database we got, and now this is the fun method. Just we are trying to print, like we will be getting the base 64 string, so we will be just printing that one, so that we will be knowing ki it's everything is working right or wrong. So, and here we are now is retrieving. We are giving the query, tell me about the annual word fire trend equal one, and we are giving the 5. So approximate nearest neighbor search will give 5 result, up to 5 result. And then multi-vector retrieval, we are just hitting that one. 5, it given the 4 result, up to 5 it will give uh, up to 5. And this is the first, these are the top. This is the first top, this is the second top, and this is the image. You can say now we are able to get the image, chart, graph, whatever is there, we are able to extract. And this is the another one is there. If you see that this is the third element, that means second index. And then we will, if you see that we are able to extract this graph. This is the biggest thing as of now. We are able to extract the not only normal image with text, but image with the chart and graph, which is the very good thing as of now. And here another hit I am hitting. Here I am able to extract the table, you can see. So here we are able to extract table, and here I ask again, then again I got the 4 document. Here we have table, text, everything we have. And then we have the this code. Mostly we are like just checking that key, whatever we are extracting is the valid image. It can be a lot of time we done some bad things, so to prevent this one, we are just checking key whatever base 65 string is there, it is really a image, not some garbage thing I have done, you can say bug. So that is the thing we are just doing to test key it is right. And then we are again retrieving another one. We got the again 4 element, and here we are just, you can say, printing. I said na ki we have created the plotting image, so you can say here we are getting the document which was a base 64 string. We are passing to the image for image function. It is again regenerating the our images, you can say. We are converting to the string, for again from string we are converting again to image, so our data is not lost. And if you want to see that what was the string, this was the string. So from, you can say, we are able to make sense of the a chart, not image, just image. Like this is the, you can say, table, but this is the pure play of the chart, which this is the one of the complex thing which we, like when I was working in 2019-20, it was the nightmare for us. Now we are able to do this, and previously we were at least able to make sense of these type of things, not completely, but we were able to. Now we are able to do the charts also. And here is the main prompt, like we got the top 5, yeah, top k, and now we are creating a template, you can say prompt. Here in the prompt, we are creating the text message, like we getting the adding the text formatted text means text message. Here we are adding, you can say, here. And then here we are adding the images. So this is the message. In the message, here we are adding the, you can say, this is, adding the text. We are adding here the images, and then we are appending to the messages, and these messages we will be sending to the human message, like it is supported of the LangChain. So we got the complete prompt, you can say, from the here, multimodal prompt. And then this is the our where we will be calling, this is the chain where you can say we will be sending the context with the input, then it will be going to the multimodal function. Enable lambda means it is the calling function calling, and then we got the our main prompt, and then main prompt is sent to GPT, and GPT output will be passed. So you can say we got the answer. And this is the retrieval pipeline where will be sending the input, and we will be like whatever we done in here, all these things. Yeah, this one, whatever we are doing, this invoke and all these things, you can say we are rewriting in the pipeline way. Same thing, but pipeline way. Like we are sending the input, we are retrieving the document, and then we are runnable lambda means split images into text type, like another function calling. So you can say converting images and all these things. And now, so now here we'll be calling this one. First we are calling the retrieval step. When we got that one, then we are calling the multimodal RAG. So you can say first this complete line, whatever I explain all the above in the line by line, it is doing the all tasks in one way. Like first extract the image I am saying, extract the context, and then send to the LM and get the answer. That's it. So you can say whole pipeline I have written in one line. And this is the I will be asking now. You tell me that it statistics is of top 5 year of the largest world 5 acre burn. So you can say I am just invoking this complete model, whatever I have created with the query. And then this is the now we are getting the answer. This was the query. This is the context we get, and this was the answer. So you can say we got the everything. Uh, Query, context, and the image. And then here I am just creating the, you can say, uh, a nice way of printing, nothing other than that. Whatever we are getting table, converting into the markdown table. So you can see that converting the image string to images. So you can see that. So here I have asked this one. So you can say I got the answer in this format. So I printed this way. Then I am sources, context I am printing from. This was the context, and images I regenerated from the base 64 string to the images. Same for here. You can say here also image was there, and same here is here table was there. The question was the table, and the another I asked the another question, like tell me about the percentage of residents burned by wildfire in 2022. I hit the query, I got that 2717. If you check here 2020, we got this answer. So, and also we are giving the 46%. This was 46%. That means we are able to make sense of the tables. We are able to make sense of the images. Even we are able to make sense of the charts and text. We are able to already make sense. And then here again, I ask that for 2020, it giving the right answer. And here, this is just Flask-based API. Suppose you whatever you created and you want to deploy, just post here multimodal RAG.qna, and you can post here, and then you can hit into the postman, and you will get the answer. So this is the complete pipeline, and this is the you can productionize also for the your pipeline, all these things. And if you want to improve, the most improvement will come from the retrieval pipeline, because that is the where we are doing a lot of task. Like in future, when productionizing, then you will be getting like millions of documents. From the millions of documents, you will be create the billions of the chunks. You can say virtual document. Those billions of chunks you have to retrieve. So most of them you will replace with Elasticsearch, and because that is very fast and will give like within a millisecond, like 5 to 10 millisecond, it will go to inside the billions of the virtual document, and will give you the better, you can say, context retrieval it give. And a lot of things also you can do in the Elasticsearch, like you can implement the NLP pipeline, stopper removal, lemtizer, all these things you can do to fine grain the more. Like suppose you want to extract uh, some keyword based but more lemtized version, like transferring and transferred both should match. So Elasticsearch provide a lot of functionality. And then vector database is there. So now suppose you can say you don't want to whatever the multi-vector retrieval is there, you want to get the top k from both, and then you want to re-rank those things. So that I will be talking in the next slide, ki how we will be getting the context from the both two. Then we are like re-ranking them using reciprocal rank fusion. That is the currently state of art for the uh, very big task. Like suppose you were having the millions of billions of chunks, and that is the where it work. And this flow work like suppose you having the doc knowledge search where people search the question, and then they got the top 10 result. In the top 10 result, he can click on the some like few more, like suppose. So that doc inside that document, now he want to ask a lot of questions, like whatever knowledge search top 10 he got, and he will select one file, and he one file or multiple, you can say five file or top 10 file he chooses. On those top 10 file he want to do like advanced rag. So that way this pipeline work for those things, like where knowledge search first he will do according in that one he will select, like suppose for second, third and eighth file he want to analyze, he will select and he will put analyze. Now this complete pipeline, this one will run, and this will give for better accuracy compared to existing one, because only three documents are there. So 100 or 200 chunks will be there, and retrieval will be high. And also you can apply the bigger model also, because very small number of the chunks are there. So all these, like whatever you are creating the documents related or the charts, table, all these things, accuracy will be very high. So that is the use case of this one, like of a multimodal RAG. And another use case is like when you are, suppose you created the system for the Google Docs, and you are the Google, or you are the Box, you are the any other contract intelligence company, and those will be having the millions of the documents. And from millions of documents, suppose average 100 pages are there, each page has two chunks, then it will be having the billions of the virtual chunks, you can say virtual documents. How you when for the one customer you having the 2 billion or 3 billion chunks, suppose you have 100, then it will be like petabyte of data. So how will be extracting? That is the way where rank fusion help. And the other ranking approach, rank based approach I will helping. I will be going to the next video how to use a rank fusion based RAG to extract the data on a very large data set.